this. We've got two equations. This is number 8 on worksheet number 2. First step is to isolate a variable. Which variable are you going to isolate? What's the easiest one to isolate? You have to look at the coefficient of each variable. What does that mean? The coefficient is the number that's stuck right on the variable. So what's the coefficient of this?
3.
3x. The coefficient is 3. What's the coefficient of this?
5.
Negative 5. Coefficient of this? 2. What's the coefficient of that?
1.
1. There's 1x there. That's the one you want to isolate. You can isolate any of these, but you might get some fractions and stuff. And you guys don't like fractions. So that's the easiest one to isolate. So step 1, isolate a variable. You're going to pick that x to isolate for. I'm just going to copy down the equation again. And then I'm going to isolate. How do I isolate x in that equation? How do I isolate x? How do I get rid of that clump?
You divide.
Nope. Subtract what?
X.
Nope. I'm going to leave x, and I'm going to subtract 2y from both sides.
X equals 13 minus 2y.
Yeah, so x equals 13 minus 2y. That's good. I finished step number 1. I isolated a variable. We didn't solve for the variable yet, but we have x in terms of y. That's what that's called. Okay? Step 2, I substitute for the variable in 1. That's what I got in step 1. In the other equation. So I use this equation to show me what x is in terms of y. Now I pick this other equation, which is 3x minus 5y equals 6. I'm just copying down that equation. And look at this, though. X is this. X equals all that. So I can remove this x and replace it by what x equals. So if I pluck out that x and put in what x equals, I end up with this. That's the substitution. That's why this is called substitution. So it's the exact same equation, but I know x and this are the same. So I can take out x and put in what x equals. Everyone see that step? Any questions on that one? Now I have one equation with just y in it. So I've done step 2. I substituted for the variable in number 1, this guy, in the other equation. Step 3, I solve for the one variable in this equation. So I have to solve for y now. Okay. How do I do that? I can distribute my 3. What's 3 times 13? 39. 3 times negative 2y is minus 6y. This is why we did all that solving equation stuff before. What do I do now? I'm trying to solve for what? Like terms. So what do I get? Good. Go on. What does that look like? 39. What's minus 6y minus 5y?
Minus 1y?
Nope.
1y.
Nope. Nope. Negative 11y equals 6. Now what?
Plus 11y.
Plus.
Run out of room. We want to leave that y there.
Minus 39.
I'm going to move that 39 over. I might run out of room here. So minus 11y equals minus 33. If I divide both sides by 11,
3.
y equals 3. Now we know what one of these variables is. We're almost there. We've done the hard part. We've done step 3. We solved for the one variable in the equation. So we know y. Now we just need to solve for x. Step 4 is use the value from step 3, that's this value we just got, to solve for the isolated variable from step 1. So we go back up to this guy, and we say, well, if x is 13 minus 2y, we know what y is now. X is 13 minus 2y, which is 3. Which is 13 minus 6, which is 7. Is that right? Yeah. Now we've done our 4 steps. We've solved for x and y. What do these values tell us? X is 7, y is 3. What is that? No, no. What were we doing before? When we graphed the two lines, they crossed at one point. That was the solution of that system. Here, if we graphed these two equations, they would cross at the point 7, 3. That's what we figured out, 7, 3. All right, Elijah, cut it.